Hi friends, this is Rashekar, a GATE faculty for electrical machines. Today in this video, we are going to discuss about the last connection, Star Zig-Zag Star. Star Zig-Zag Star. Let's see. Generally, we discussed earlier, in star the floating neutral is there and EMF is not sinusoidal. And there is no closed path for third harmonics. That's why this is modified as Star Zig-Zag Star. In this, we can provide a closed path for third harmonics, or we can eliminate the phase third harmonic voltages, and the EMF is sinusoidal and the neutral is stable. In this case, the neutral is stable. This is the advantage of Star Zig-Zag Star. Let's draw the Star Zig-Zag Star connections. Let's draw it. See, for example, this is my primary winding. This is my primary winding, which is star connected. This is my primary winding, which is star connected. A, B, C, A2, B2, C2, A1, B1, C1. This is my star connection. And what about zigzag star connection? For zigzag star connection, take the winding here. We know this is divided into two parts for zigzag connections. And here A by 2, B by 2, C by 2, A1, B1, C1, A2, B2, C2, A3, B3, C3, A4, B4, C4, and the dots are at this condition only, here only. This is simply the connections, windings of zigzag. Now this is star, so zigzag star. For example, I am taking the neutral here, and we should connect in series opposition, right? That's why this A1 is connected to B3, this B1 is connected to C3, and this C1 is connected to A3. Now see, these two are in subtractive polarity. These two are in additive polarity. These two are in subtractive polarity. Draw the arbitrary star. This is A, this is B, this is C, this is A2, and this is B2, and this is C2. This is arbitrary star. Next, now draw the vector diagram for this zigzag. I said you these two are in series subtractive manner. Nothing but if A is like this, here the A should be like this. Here the A should be like this. This is A by 2. And if B is like this, here the B should be like this. This is B by 2. C is like this. Here C should be like this. This is C should be like this. This is C by 2. Where is A? Sir? A by 2. A by 2 is connected to B3. B by 2 connected to C3. C by 2 connected to A3. Again same. Now let's draw this additive polarity vectors. Additive polarity here A3 to A4 A by 2, A3 to A4 A by 2. But listen here, these two are in additive polarity, that's why my A is in upward direction. Here also A should be in upward direction. Here also A should be in upward direction up to A4. This is A by 2 and this is actually A. This is actually A. One is completed. And next one, from B3 to B4 B by 2. From B3 to B4, where is B? B is like this. In the same direction we have to take. This is here B3 to B4 B by 2. So this is actually B. And next C3 to C4 C by 2. My actually C is like this. Here also actually C should be in the same direction. C should be in the same direction. This is C by 2 and this is C4 and this is actually our C. A, B, C. A, B, C. Yeah, clockwise direction, phase sequence. Now superimpose them. This is 12 o'clock. This is 6 o'clock. And 5, 7, 11, 1. Let's take the primary always at 12 o'clock. We know this is capital A, and my small a is like this. My small a is here. Nothing but the star zigzag star provides us minus 30 degrees or simply 30 degrees lagging displacement. 30 degrees lagging displacement. The star zigzag star gives us 30 degrees lagging displacement. This is the star zigzag star connection for first configuration. And we know that the second configuration also is there. For zigzag connections we have two configurations. So let's take the second configuration. For second configuration, the primary is same, just we have to change the secondary. Just we have to change this secondary manner. So let's check it how it was. Let's draw again. Right. Let's see here. Again I am drawing there. These are the secondary windings. Yes, these are the secondary windings. And here we know this is A by 2, B by 2, C by 2. A by 2, B by 2, C by 2. And next here A1, B1, C1, A2, B2, C2, A3, B3, C3, A4, B4, C4. Right? Now always the dots should be here only. This is fixed. Right. Now we have to draw the diagram, star zigzag star diagram. Now take the star notation here. Nothing but these two are in additive polarity. Now these are connected to here. Now these two are in subtractive polarity. Then draw the arbitrary star. Let's draw the arbitrary star. First these two are in additive polarity. So in additive polarity, that's why A is here and here also A. This is A by 2. This is A by 2. In upwards A by 2 and B by 2 and C by 2. Where is my A by 2? A by 2 is for B4. B by 2 is for C4. C by 2 for A4. C by 2 for A4. Right? This is the initial vector diagram. Now for this, these two are in subtractive polarity. So subtractive polarity, that's why we have to draw in reverse. So first of all, from where is A? From A4 to A3, A by 2. A4 to A3, A by 2. Where is A? In opposite direction. That's why this is A in upwards. Here A should be in downwards. Here A should be in downwards. This is A4 to A3, A by 2. And this is our actual A. This is our actual A. Okay? Next, where is B? From B4 to B3, B by 2. Where is B? B is in this direction. So here, exactly upwards. Exactly upwards. This is B3. This is B by 2. And this is actually our B. This is actually our B. And next one, B is completed. Next, C4, 3, C, C by 2. Where is C? C is in downwards. So here exactly upwards. Here exactly upwards. This is C3. This is C by 2. And this is C. A, B, C. A, B, C. A, B, C. Is same. So let's superimpose on a clock. Let's superimpose on a clock. As usually, here the reference vector A is at 12 o'clock. Where is my A in this? Where is my A? Here is my A. Here is my A. So like this. This is my hours hand. This is my hours hand. Nothing but another one is here 0 minus 30 degrees is the first one, and next one is the 180 plus 30 degrees. 180 plus 30 degrees, nothing but 210 degrees of displacement. 210 degrees of displacement. Like this, these are the star zigzag star connection diagrams. Star zigzag star connection diagrams. This is simply about the three-phase transformer connections. Delta delta, star star, delta star, star delta, delta zigzag star and star zigzag star. Right? Now the line turns ratio for star zigzag star. What is the line turns ratio? So star zigzag star, what is the line turns ratio? Line turns ratio. Line turns ratio. The line voltage of star. Line voltage of star is root 3 times of phase voltage. Line voltage of star is root 3 times of phase voltage. And what is the line voltage of this star? This is also root 3 times of root 3 into V phase by 2x. We calculated now already. In before session we calculated. Now tell me what is the answer? Root 3 into V phase cancelled. So the line turns ratio is x is to root 3 by 2. X is to root 3 by 2 is nothing but x is to 0.866 is the line turns ratio for star zigzag star connection. Star zigzag star connection, x is to 0.866. This is for zigzag connections. Did you understand? Are you okay? Right. Thank you, sir.